Respected Chairman, uh, members of the audience, good afternoon, one and all. All right, so this is Jeevish Gurumoorthi. I head the navigation and sensors business in Honeywell. This is a very relevant topic. Multiple times you've heard about it, and for the last 3-4 years, this has been a very important topic in the military aviation and military industry. How we solve for reliable position, navigation, and timing in contested space, right? With the jamming and spoofing and the countermeasures also becoming stronger and stronger. How do you continue to work on this? So Honeywell is a technology house. We are not a platform OEM. We are a technology OEM. We do everything nose to tail in an aircraft. We supply critical technologies for various land, air, and marine platforms. Navigation is one of them. And we are a strong navigation player in the sense, we are the largest manufacturers of inertial systems, ring laser gyros, fiber optic gyros, MEMS-based sensors, everything in-house, plus a host of other technologies required to give full stack navigation capabilities for platforms. So I was telling you nose to tail on everything, commercial aviation, military platforms, the emerging unmanned systems, or even urban air mobility. The whole host of next generation technologies that we work on, avionics, communication, navigation, power systems, propulsion. Specifically, the navigation and sensors business, which I belong to, we have a very long legacy, going all the way to World War II, where mechanical gyro-based stabilized sights, Honeywell started making. Of course, that was Perry at that time. And then the ring laser gyros. The ring laser gyros were invented in Honeywell in the 1960s. So we have a very strong legacy there. And today you look at commercial aviation, any aircraft that you fly, Boeing, Airbus, narrow body, fixed, wide body aircraft, the primary inertial navigation system is a Honeywell navigation system powered by the ring laser gyros that we make. And as technology started evolving, our sensors have gotten better and better. Our abilities to drive performance, extract performance, reduce size, weight, power has gone better and better. So today the sensors are very small and can deliver extraordinary performance compared to what's available in the market. And then on the MEMS side, we have our own silicon foundry. We make everything in-house. So very strong levels of capability there as well. We provide and support applications in the entire spectrum of applications in air, sea, and land. Why do Honeywell, why is Honeywell a preferred player for military OEMs and for militaries as well? One is performance. We are state of the art. Reliability, proven systems that have been performing in the field, even those delivered in the 80s are still performing extremely accurately after several years of operation in contested spaces, in challenging environments. That's why people come to us again and again. And the ability to make at scale, right? You want lower cost, cheaper, a reliable source of supply. Supply chain is a major constraint, reliable source of supply. So that's where Honeywell comes in. And also diversified, supply structures. It's not one country, it's spread across. We all grapple with geopolitical constraints, tariffs, embargoes, export licensing related stuff. So we have variety of technologies to ensure our customers around the world have access to various forms of capabilities from different sources. So today's topic primarily on what we call as alternative navigation in the industry. That is variety of technologies that enable GPS denied, GNSS denied operation of platforms in different scenarios, which complement core navigation today. So the core navigation is and will continue to be inertial navigation, which is what is our core business too. Gyros, accelerometers. Yes, GNSS fusion has kind of been the norm over the last, I would say, 3 decades of the Navstar GPS being in existence. And now, with that, the availability of GPS GNSS being suspect, the additional complementary technologies, vision, celestial, magnetic anomaly, gravity anomaly, radar-based aiding, radar-based terrain aiding, various forms of technologies that are available and that are continuing to evolve is something we continue to complement with our core inertials and offer comprehensive end-to-end capabilities on forward-fit solutions as well as retrofit. See, each technology has its own boundary conditions, right? So for example, vision. Vision is very good when you work at a slightly higher altitude. You have good terrain data. You can do good scene matching. Of course, algorithms are a big thing here. To what extent you can make them work. But then there are some constraints. For example, in a cloudy environment, your daylight cameras may not work. You have to switch to a different mode of camera, or you might not get visualization at all of the ground. And what's the complementary technology that you can add, right? So it's basically a combination of technologies needed for that platform, the type of ConOps, the types of missions that the user would like to undertake. The right combination of technologies with the right core inertial sensor will help get reliable PNT, reliable position navigation timing, and help achieve the mission requirements. So yeah, we work on all of them. Most of them are TRL 6+. Many of them are in the field, in production, well proven. We have our own test aircrafts. We've been working on these technologies not today. GPS denial is part of the conversation in the last 2 years, 3 years. In India, the amount of conversations we have had over the last 2-3 years is enormous, especially in the last 12 months has been, the conversation has really, really heated up. But we have been working on this for a decade, right? We've been working on this not just in the US, but other global sites also, including in India. We've been working on alternate navigation capabilities, vision aiding, visual odometry, visual scene matching, again, other forms, radar-aided systems for tactical systems. Last year in the EP6 trials, our systems have performed exceptionally well. Many of the tactical platforms, we've been able to support them with EW survival capabilities. We've started making these products in India. We have, even before all of this happened, we were already plugged into the global supply chains. We have very strong supply chains in India, electronics, manufacturing, mechanical manufacturing. We were already doing this in India, even prior to many of these things happening. So which was very easy for us to bring fully Indian manufactured products directly to our market, work closely with the OEMs. Many of the OEMs we have been working much prior to some of these ConOps evolving, right? The electronic warfare ConOps evolving. We've been working with them very closely in developing. In fact, we've had a lot of learnings coming in while working with them, and we have continued to improvise the product. What you see today is one of the latest generation. After 2-3 iterations, we have some of the right capable products out here, and we are also working on very flexible architectures to take it to a variety of platforms, because the number of applications, number of platforms, just in the UAS space, if you see, you go to any big OEM working on unmanned systems, you will see a dozen platforms that they're working on. Different ConOps, different requirements, different sizes, different weight class, different operational altitudes. So we have come up with flexible architectures where the core nav algorithm, the vision capabilities, some of these can be hosted onto the user's target hardware itself. Plug and play with something that the user is already using or the OEM is already using on their platform. Use their cameras, use their other sensors, and then bring in additional capabilities. So that's how we've been working. And this is an agile space. The platform OEMs are agile. Our group is equally agile too. I cannot speak generally for large corporations, but I can tell you for a fact that our group is very agile. And we have agile teams in India as well, continuously supporting these capabilities. Some of these systems, you can see the test results. Vision with high quality MEMS sensor. Again, MEMS is no longer cheap MEMS. Today, Honeywell has MEMS which can gyro compass. So that means extremely high end. We have invested heavily in MEMS. It's the state of the art that MEMS can get to. That means the biases that you would see in the sensor has come down tremendously in the MEMS design. So you can gyro compass with MEMS. So very small, very low form factor, but you get RLG, FOG type accuracy. So MEMS with visual aiding, MEMS with terrain matching, radar, radio altimeter, terrain-aided navigation, or MEMS with, other forms of, radar odometry, can get different levels of performance with different classes of platforms. What you see here is sub 5 meter level accuracy for something with vision and inertial. Vision, we've been flying this for several years now. It's not now. We have our own aircrafts, test aircrafts. We have an Embraer aircraft. We have multicopters. We have a AW139 in which we have all of this equipment mounted, and we keep doing trials again and again and again. Keep improving. Keep trying out different sensors. Keep trying out different algorithms. Continuously keep, as the ConOps keep improving, changing. Requirements keep changing. We continuously keep working on them. Work closely with users across the world. We learn from everybody. We improvise. We are there, helping, the platforms operate fully in GPS navigation, in environments, meet sub 10 meter accuracy consistent. So this is the system that I talked about, that cleared EP6 trials with several of our, tactical OEMs. These use millimetric wave radar-based velocity aiding sensors, along with our MEMS inertials, made in India through our global supply chain partners. And we have variations of this coming up as well, right? I mean, for this bird, that's fine. You can put radars facing downwards here. How do you do it on a slightly fast-moving fixed-wing bird where aerodynamics becomes an important factor, right? I mean, so we're working on configurations that can support that. We're working on where space constraints are there. We're coming up with single board, a credit card sized INS GPS integrated solution which runs the algorithm, but then you plug in with different sensors, through an interface electronics. Enough jamming spoofing trials have been done. We have been part of this for the last, I would say, 4 or 5 years. In India, my teams have seen enough, not just with one OEM, but multiple OEMs, been with them in trials, seen the ups and downs, and continue to get up and pick up and improvise and learn and make the product successful, make our customers successful, at the end help user have a very reliable solution to deploy at the time of need. The newer systems, newer tech that we are working on, one is LEO PNT, low Earth orbit PNT, relying on non-GNSS constellations, emerging constellations. You have players working on LEO PNT these days. You have Iridium who has it. You have newer stuff coming in from Europe. You have there is also an emergent LEO PNT effort in India as well. So a lot of work is happening. We're continuing to work with a lot of players to continue to work on this. Again, as I said, flexible architecture, putting together a full nav stack, a nav chain for a platform is a platform-specific unique effort. So you need to understand the platform. Indra Balan sir spoke heavily about requirements for safety-critical engineering, reliable architectures. We come from the aviation world, right? And Honeywell is an avionics.
Mr. Gurumoorthi, we'll have 2 more minutes.
I will finish 30, 40 seconds. Yeah. So that's our expertise. That's what we bring. And by the way, Honeywell has been here doing engineering for 30 years as a GCC headquartered in Bangalore. We have 3,000 aerospace engineers working on various global programs. The expertise exists. We just have to tap into it. That's a message I would like to place in front of you. Tap into the expertise that GCCs have built over 2-3 decades here. They have labs, infrastructure, a lot of stuff exists. They may have been just external facing, doing global engineering, sitting out of Bangalore and Hyderabad and some of these places. But look at the expertise that's there, look at lab infrastructure out there. How do we plug in? How do we bring our learnings? Because these are all Indian people, these are all Indian engineers who have spent 2-3 decades of their career learning from the best in the world, deploying safety critical capabilities. We work closely with the DRDO agencies. We work closely with HAL, with Bell. We do projects with them. So we bring that expertise to this play. And this is a new industry, new emerging industry. We can offer a lot by just bringing the expertise and guiding the emerging ecosystem. Yep. Again, I'll leave this slide. Variations of sensors. You name the platform, choose a type of platform, group 1, group 2, group 3, mail, hail, whatever. You pick your sensor, you pick your navigation architecture, you pick your aid for a particular ConOps, for a particular mission. We'll stitch them together. You say you don't want this country's capability, you don't want, ITAR, you don't want this, you don't want that. We can pick and choose from a suite, from a menu of options available to stitch together a capability and, make it work on new platforms, make it work on retrofit platforms. We have a, large fleet of existing, hardware that we want to make it function in contested space going forward. We can be of enormous help in doing all of that. Thank you very much, sir. Thank you for the opportunity. Thank you for being a wonderful audience. Thank you.